highly communication, not necessarily written based. This type of population, they have difficulty with lengthy amounts of text, but it's a short, concise visual. We do quite a few activities pre-college. I call it K through 12, but it's really more like 6 through 12. Every summer we have many camps through the women engineering programs that they have a blast. They just to come into an assembly line and assemble a fan and then go tell their parents what they did has been a huge success, more than we anticipate. This is only a half an hour activity for them with just a very quick discussion about what went on, what would you do better, that kind of thing. But it turns to be one of our most effective recruiting tools, but also enticing younger students to pursue technical fields, STEM fields. I'm not going in order, but we started to do some activities with the Department of Labor in New York State, in which workforce development for some of the recently founded excellence centers around the area. We have one in infotonics, another one in optics around Buffalo, Rochester. And they're lacking the manpower to do the type of work that they need. So we're starting to do some workshops for them. And we do have quite a few universities come over the summer, and they're interested in sending their students to just have a week-long or 2-week-long intense laboratory-based experience. Finally, there's a big open house in May where all the labs and the entire university is open to the community. The university gets about 30,000 people visiting, kids, parents, grandparents, everybody can come and just walk into the lab. And we let them visit our facilities as well. Okay, so let me go about explaining the components. I'm going to talk about facilities, curriculum, and then wrap it up with corporate relationship and improvement. So personnel, we have about 3 faculty who are deeply involved in the lab. We have one person in ergonomics, human factors and safety, who's going to start developing exercises and activities around those topics. We have another person who actually comes with an industrial background. He spent 30 years doing lean and lean logistics at Kodak locally, and now he's a full-time faculty, and myself. We keep about 3 to 5 students in the staff. We open 40 hours a week. Students can schedule time in the facility with their teams because there's a lot of offline assignments. One intern. I call them intern because we don't pay them. So I don't know if it's accurate or not, but there's people who actually want to work in the lab for free. And I'm usually short-handed, so I take them. And 2 affiliated faculty. The associate dean is also deeply involved from the support standpoint. And we have one faculty who is a deaf faculty who works at AT&T, and she supports all the deaf students. We have all these activities ranging from courses, credit-bearing courses, all the way to camps, tours, open houses, practicums. And our facility has 2 bays. This is an old picture, actually, of bay number 1, which contains a main floor, a couple lines, and a mezzanine on the back, where students, usually we have lab class sizes of about 12 people, maybe 15, and then we break them in half, and half are working on the floor, the other half are just hovering over, looking at the performance and on the mezzanine. And we're projecting on the screens the metrics and trying to go more real time on some of the statistics like throughput, cycle times, and WIP, so on. Everything you see can be quickly reconfigured. Most of the equipment, it's either on wheels or is modular. And again, just trying to enable that sandbox idea of the student being able to implement their system, their thoughts. Bay number 2, it's where we have the warehousing capability, inbound and outbound. This is new. We just got the space over the last year. We just got the equipment finally installed last month. So that all that equipment is kind of brand new. We have on the left It's a pick-to-light area. Mike should recognize those racks, where we have 3 bays, about 120 lights. We have a high-density bay, the one on the right, and 2. Those have multiple colors, multiple lights, multiple signals, type of picking instructions. You can induct batches, single individual orders. You can reconfigure that in 1, 2, or 3 bays if you want to. So have a single picker, 3 pickers, and go by that. And that's one of the activities. The one on the right, lower right, is they're called built-to-light benches. And what they're used for is you get instructions shot at the students through this touch screen, and all of these bins will have some sensor-directed picking. It might be light, it might be an infrared, or it might be a toggle limit switch. So actually the faculty who's doing the ergonomics is thinking about working with the company who supply this equipment and doing research on the productivity of different sensors in the picking operation. So we may actually start dipping a little bit on research as well, even though it's a teaching facility. So you have all the parts and tools in these bins. You get the instructions, you start picking, and you can do a pre-assembly, or you can form a kit that you can actually forward to an assembly line. And we have 2 of those in there. All those stations, all the equipment was built in-house by students, designed by students, and installed, well, by us and the companies. Okay, the first couple years, we were pretty much a stowaway exercise. We had a couple of assembly lines that I would set up in the main CNC machine floor against, all advice from the director of the facility. And then I had to take it apart after the lab and then put it away. So it was a stowaway facility or setup until we moved to a different building. And this area, 1150, which is the bay that you saw, was a multi-purpose computer lab, a grad student office, and we secured just a tenant space on the corner in 2003, so I did not need to put it away afterwards. So it was a permanent setup. The exercise became part of multiple courses. Our freshman course in IE, the introduction, had a quick come and look and come and play exercise. Then we also had 2 senior level courses using the facility, so that increased activity got us some more space. All along, Toyota, who's been recruiting from our department, from our college, I should say, kept popping their heads and saying, well, we like what you're doing. We cannot train our students similarly the way you're doing, And I told my department head, we got to call their bluff. And we have to put a proposal to Toyota, which, you send a proposal and then you don't know if you're going to get it, so you're not worried too much. Boom, you got it. So they did. They actually gave us money and a sponsorship in the name, in the form of naming the lab. And I really had to sit down on this one and think about the implications of putting a name to a lab, branding education, and I had significant discussions. It's like, turning away money. Significant discussions with them and within our group to say, what does this mean, really? And we ended up, of course, taking it. But 2 things were kind of discussed early. One is the name doesn't imply sponsorship or branding. We don't, and they never have asked us to do anything education-wise. We come into the lab, it bears the name. What we teach is industrial engineering, production systems, problem solving, and so on. That it happens to be aligned to what they do, fine. But we don't really necessarily follow what their advice happens to be. Of course, we communicate constantly, and some of that is good feedback, but not necessarily. So we ended up affiliating the lab with Toyota and receiving that sponsorship somewhere around 2006, and that allowed me to really take over that space, which is what you sort of saw there, and expand the activities. At this point, something really interesting happened, and it was we're halfway into an ABET review, and we were thinking about really revamping the curriculum, especially when it comes to the manufacturing courses. At some points, most departments either dropped the name manufacturing from the title or went to systems or diminished the emphasis on CNC machining and those courses that require a lot of hardcore manufacturing, if you will. Well, we sort of faced that as well. And that gave us an opportunity to really design a course, a complete, entire 10-week course around a facility. Okay, we have this lab. We want to teach production systems. How do we do this? So that exercise was very interesting in the sense that, okay, so I have a production line. Can I have I teach line balancing. Can I have an exercise where the students can balance a line, perform in it, see that the bottleneck is not where you wanted it or it's not quite what you wanted to do it again, and so on, and then do that with 10 different topics. So that became one of the mandatory courses in IE, one of the most successful courses we ever had from a feedback perspective and value perceived, at least. All the assessment is mostly anecdotal, but it tends to be very well received. So this is where we stood at 2006, and we started supporting more courses, and in 2009, Toyota Foundation USA actually asked us to submit a proposal to them for a significant amount of money, and it got funded mostly to support some of their K-12 activities, but that allowed to, and I don't know how it is in every institution, but getting space is very political. Where I'm at, extremely political, and it requires not only money, but context and, it's who you know and what you. But we ended up getting it with the blessing of a provost. And finally, the last 2 years, my job has resembled less that of a faculty, but more of a, I've been supervising demolition, construction, installation of transformers and Ethernet cables. I mean, stuff that I wasn't envisioning doing. And then procuring the equipment. You know what it takes to put a pick-to-light system that is on only 120 lights? How many, do they have a pick-to-light system in Joann stores? No, they didn't. All right, well, a typical pick-to-light system might be 5,000 to 10,000 lights if you've been to those warehouses. Some as many as 30,000, some as few as 4,000, 3,000. Nobody wanted to do 120. So I got more projections than I got them from NSF, so, which is quite a few. So if you actually try to work with a company to come down to your size, you're in academia, that was quite a bit of a frustrating experience. And then you go to the trade shows, which I had to go anyways, and try to hunt for the right piece of equipment, and I want real-time statistics, so your software doesn't do that. And finally, we got it to work. I think it was working when I left. And like I said, this is a brand new implementation.
Why didn't you choose voice then? Because that works better with smaller.
I'm sorry, what?
Why didn't you choose voice picking? Bearing in mind that works better with smaller.
Yeah, we consider both. We try to have, and actually this is where maximized flexibility is, we're going to do voice in the future, not just right away. We didn't have enough money for both.
Well, Rich is smarter than me, so he worked out that it won't work with deaf and hard of hearing.
Well,
That makes it more.
that's a good point. Yeah, this is visual, the voice is not. Voice has also, just now they started to overcome the voice recognition impediments. It's getting better just now. So we're going to go voice, not right away. We had to choose one of the two.
It's more boundable at bottom level.
Well, think about voice recognition. You got to train the voice system. Why don't we use voice instead of light? And one of the disadvantages is we